So, I've stacked some gold coins here, and since I live in Malaysia, I bet you $1 you can guess what's gonna happen next. Ready?
Well, that was unexpected, to be honest.
Again, any guesses? Well, other than our buddy here having an upgraded armor, he also has beautiful eyes. Finally, this time around BB-8 stopped right before hitting those gold coins. But why? Let's do some analysis. Other than being an upgraded project, what else does make this new invention stop midway and work better? Well, technically everything. It has an Arduino, 3 lithium batteries for power source, a motor driver, and an ultrasonic HC-SR04 sensor. That is something that we are going to talk about today. We use the ultrasonic sensor to measure the distance between an object and the sensor itself. It is cool that it needs no physical contact or a ruler to calculate the distance. Inspired by How to Mechatronics, let me show you a cool demonstration on how accurate the ultrasonic sensor works. Here we have a ruler, not to measure the distance, but as a reference to see how well the ultrasonic sensor can calculate. The readings displayed on the screen is very much similar to what we are measuring with the ruler. Pretty cool, right? Also, just in case if you somehow feel this ruler has something to do with the distance measurement, let's just yeet it. And it still works like a charm. Notice how the distance reduces when I bring the object closer and increases when I take it a bit far away. So, how does it actually work? We know what it does, but how? Well, the answer is simple. Waves. Our ultrasonic sensor has 4 pins. VCC to provide power to the sensor, which is 5 volts, ground pin as the negative terminal, trigger pin and echo pin. Our trigger pin emits an ultrasound with a frequency of 40 kHz. Once there's an object to interfere the waves, it bounces back and it will be received by our echo pin. So, in simple and logical terms, the longer it takes for the echo pin to receive the ultrasound, the bigger the distance is and vice versa. In technical terms, we are currently calculating the time it takes for the echo pin to receive the ultrasound. Well, we really don't need that now, do we? Imagine an old grandpa dropped his glasses and looking for it, then a boy suddenly comes and replies, "Grandpa, it's just 50 microseconds away from your hand." We gotta do some coding in order to avoid that. We need science for that. Speed is equal to distance divided by time. Rearrange this formula and distance is equal to speed times time. Now, we get the time from the ultrasonic sensor and the speed of sound is approximately 343 meters per second. So multiplying the time by 0.034 speed of sound in centimeters per microsecond and we'll get the distance. But we are not quite done yet. By now we are not calculating the original distance, but the distance in which the ultrasound has traveled. For example, if there's a portrait of Leonardo da Vinci 50 centimeters away from our sensor, the ultrasound emitted by the transmitter needs to travel 50 centimeters from our sensor to the object, and once it hits the object, it bounces back and needs to travel another 50 centimeters to be received by our echo. So, the reading would be 100 centimeters. In order to avoid that, we simply need to divide the value we get by 2. Let's get back to our project. I have programmed the Arduino as such that if the ultrasonic sensor detects an object that is lesser than 5 centimeters away, it needs to stop the DC motors from operating. Hence, our buddy here stops midway and prevents the beautiful stack of gold coins from falling. Well, there you have it. You have learned how the HC-SR04 works in lesser than 5 minutes. Subscribe for more videos like this. And before I get to say stay tuned, here's a bonus for you. Lesson of the day. Proper amount of power source is essential for a project to work at the finest level. Providing less of it prevents your innovation from working, and making it overpowerful leads to catastrophe. As always, stay tuned.